Welcome back. In this video, we take a closer look at climate information services and concrete tools and examples. For those of you who want a more detailed introduction on climate information, there is a short e-tutorial on the UNCC eLearn platform. For now, let's continue. We need to gather so much more for our journey, fruits remaining to be plucked, springs awaiting our visit. When it comes to adapting to changing climate, of course, climate information is necessary. It is fundamental to understanding and managing climate risks and integrating adaptation into policies and actions. Climate information describes past, current, and future climate conditions and provides information on hazards and exposure. It can help decision makers answer questions such as which climate variables are expected to change, precipitation, temperature, where are these changes expected, and when. On a global policy level, accurate, reliable, and timely weather and climate information is central to empowering nations, saving lives, and strengthening livelihoods. A failure to provide warnings on fast-acting storms and other extreme climate events affects production levels and hinders economic development. And yet, producing and communicating climate and weather information to decision makers is challenging.
And at the moment, while a lot of the information is now being collected, a lot of the hydromet information is being collected, and that's a very positive aspect, that there has been a much bigger improvement in the availability, or rather in the collection of climate information. But there are lots of issues around access to climate information. Not all the planners have access to it, and even when they have access to it, it needs to be packaged in the appropriate way.
Think about two of the challenges Rohini just mentioned. First, climate information requires a functioning network of weather information infrastructure as well as technical and institutional human capacity. Currently, availability and quality of climate information is limited. Weather data is often difficult to find or not available at all for the period or variables which are of relevance. Second, climate-related data and analysis should reach those who need to make decisions: policymakers, planners, farmers, and fishers. Essentially, there is an information mismatch between meteorologists on one hand and policymakers and farmers as the end users on the other. Information and research studies must be designed in a way that responds to the end users. Programs like UNDP's Climate Information for Resilient Development in Africa, also known as CERDA, which is currently working with 11 African LDCs, provides best practices on how to build end-to-end climate information systems and address these challenges. For example, CERDA uses low-cost technologies to provide local observations via cellular networks and computers. CERDA also looks at putting end users first, which in the case of agriculture means providing farmers and communities better information on weather events and likely characteristics of the upcoming season. Let's look at some of the ways climate information and data can be useful in assessing agricultural risk. Small changes or trends in weather patterns may lead to significant increase in agricultural risks. Identifying trends in climate data that may affect agriculture can be important for crop management decisions made today. There is a need to consider not only monthly or seasonal averages, but also characteristics which are linked to particular decisions. For example, predicting the start and end of the rainfall season can help farmers decide which varieties to plant and when to plant them. So, if you can identify the thresholds beyond which your crops will be under threat, you can prevent or prepare for the future vulnerability of crops. Thresholds of climate variables can be useful to assess more direct impacts. They might not be so helpful in assessing the combined impacts of several climate variables working in tandem or in opposition. For example, the water balance or the water available after rainfall and evaporation is dependent on a range of variables, including rainfall, winds, humidity. Let's look at droughts. The greater frequency of dry spells and droughts is perhaps one of the most significant climate change impacts for agriculture and food security. One of the tools introduced this week is ACES, an agriculture stress index system developed by FAO. ACES generates a map of hotspots around the globe where crops may be affected by drought during the growth season. This information can be verified and used by the ministries of agriculture of the affected countries. Climate information can also inform decisions on long-term sustainability of an area, where adapting might lead to livelihood diversification or new production systems altogether. Now, let's introduce another tool: Modeling System for Agricultural Impacts of Climate Change, or MOSAIC. MOSAIC is a system of tools and models that helps address the need for an improved science policy link. The software facilitates a collaborative, integrated research from different subsectors: climate, crops, water resources, forests, and economy. It is a tool to fill information and capacity gaps, and it provides a range of models and techniques suitable for decision making and helps countries answer the question, what do we need to adapt to? If you want to know more about how these tools work, check out the lecture notes for this week. Congratulations, you are finished exploring your first island and you're halfway through the course. Don't forget to test yourself with the practice exercises and complete the quiz. See you next week.